Spectrum. What do you know about a spectrum? I think you must have seen a rainbow. Rainbow is an example of spectrum. If you have seen rainbow, that means you have seen a spectrum. Rainbow is a spectrum of visible light, the light we can see, right? So, rainbow is an example of a spectrum. Now, taking it to the board, we have two main types of a spectrum. One is emission spectrum, and the other one is absorption spectrum. Emission spectrum is again of two types, continuous spectrum and then discontinuous spectrum. So, let me explain it to you on the board. Imagine you have light, white light, right? So, white light consists of multiple wavelength lambda 1 to lambda 7. You take a sample of gas, you take a sample of gas, and gas absorbs, let's say, lambda 3 and lambda 5 is absorbed by the gaseous atoms for their excitation. What is excitation? Excitation is like this. You have, I'll take another page and explain it to you on that. I'll take another page. What is excitation? Excitation is this. You have atom, and inside atom you have orbits. An electron of lower energy absorbs energy, let's say light energy it absorbs, and it jumps to the higher orbit. So this is known as excitation. So excitation is basically jump of electron from lower orbit to higher orbit. There is first orbit, second orbit, third orbit. So energy of first orbit is the lowest, energy of third orbit is more than second orbit and first orbit. So electron absorbs and goes to third orbit, or it can go to second orbit. It can jump to a higher orbit and by absorbing radiation, right? And this electron stays for some time, and then it comes back to its original orbit, that is first orbit. When it goes to the higher orbit, it absorbs energy. When it comes or falls back to the original orbit, it emits radiation. Clear? Goes to higher orbit, absorbs energy, jumps from higher to lower orbit, it emits energy. Just remember this principle. So, when white light is passed through a sample of gas, you have multiple gaseous atoms. So, lambda 1 to lambda 7, 7 wavelength are there in the incident light. This sample absorbs lambda 3 and lambda 5, and lambda 3 lambda 5 is absorbed in the gaseous sample for the excitation of electrons, and remaining light is transmitted. Transmitted light has lambda 1, lambda 2, lambda 3 is missing from here. So, lambda 4, lambda 6 and lambda 7. Lambda 3 and lambda 5 are missing because they were absorbed. Now, you pass it through a prism, and passing from the prism, it splits into multiple radiations. So, this arrangement of, let's say, this is lambda 1, lambda 2, lambda 4, lambda 6 and lambda 7. So, this arrangement is known as emission spectrum. This arrangement this is absorbed, white light is passing, electrons excite, then transmitted light is passed through prism, and it splits into multiple wavelengths. This arrangement is called absorption spectrum. This arrangement is called absorption spectrum. So that's absorption spectrum, right? Now, emission spectrum, what will happen is electrons which went to the higher orbit will return to the lower orbit and they will emit energy. So they will emit energy, and that energy will again be captured after passing through a prism. They will again split and you get a spectrum. This spectrum will have the absorbed wavelengths. Let's say lambda 3 and lambda 5. This will be known as emission spectrum. Emission spectrum because electrons went back to the original orbit and energy was emitted. Energy was emitted, that's why they are called as emission spectrum. Alright, so here if we take white light, you pass through a prism, you get a continuous spectrum which is basically a rainbow. Then you get absorption spectrum where few radiations are absorbed. You get a black lines. You get black lines where radiations are absorbed. When electrons jump from during the excitation, they absorb light, and during their return, they emit light. So this is the emission spectrum where background is dark and few colored lines are observed. And in absorption, background is bright and few dark lines are observed. So that is one is absorption spectrum, the other one is emission spectrum. So if you put them both together, you get the original spectrum of light, which is like a rainbow. Alright, so that is all about the spectrum. We have explained all the things and that must be clear.